it's recording. Is it recording? Why is it not recording? Does it say it's recording on y'all's end? Oh, there it is. Okay. I might have lost them.
Gummy bear?
Little woolly mammoth.
Oh, they lost me. Are y'all there? Oh. Oh, and Angelo is here. Can y'all hear me? Are y'all there?
Yep.
Okay.
Yes.
Yep.
I don't know why it was glitching again. Well, surely it's because I don't have great internet.
That's what I said.
Yep, gummy bears have the softest bite. Okay, triple integrals. Oh, and I did finally find where they talked about average value of a function. It's in 6.2. So that's the same section that y'all did the like shell method and the disk method and all that. So, all right. So with triple integrals, and since I don't see any of y'all, can somebody share their face with me so I make sure that I'm not frozen on y'all's end? Thanks, Joe. And Mary, thank you. And Josh, thanks. Because as soon as I know that I'm talking and y'all aren't moving, that means y'all don't see me. So, all right. So we're going to just extend what we did in 15.2 to a third dimension. So if we have what is considered a box, so it's a three-dimensional thing that has these as its bounds, we can consider this in terms of these bounds that are going to be placed out here. So if I was looking at the triple integral of this thing, where my bounds are going to be here, so this is talking about the x, the y, and the z. So I could set this up. And so if I have the z on the inside, I'm going to use the z bounds on the inside. If I have y in the middle, that goes in the middle. And z, or sorry, x is on the outside, so that's on the outside one.
Wouldn't there be a good way to do those in order so that way it's like a much easier like problem to solve, or does it matter?
It doesn't matter. This is just how the book set it up because I wanted us to do it this way and then see what happens if we switched it. And again, when we do these things, we can look at it in that way, integrate the middle part, then expand it out, and then expand it out. Missing Cade, Joe, and Julie. Did y'all get that? What did y'all get?
I took the derivative, my bad.
Okay, Mary's eyes are open. Okay, good. All right. And Josh, you're finding it?
Yeah.
Okay, cool. Okay, so now I'm going to put this in for that part, and then I'm going to look at the integral. Well,
Can we just pull out the e to the 16 minus e to the minus 6
yep, and the over 3,
and the over 3?
and also technically the x squared too, because that's going to be treated as a constant because he's not a function with respect to, or sorry, a variable that's dealing with y. So I'm just going to pull all that mess out.
I just got a real quick question.
Mm-hmm.
Like I might have missed something. Why is it e to the y minus 6?
It should not be.
Yep.
That's, thank you.
Okay.
That was my carelessness, -1 there. So that's going to equal so that's going to just give me make sure that's what they booked that. Yeah. And then if we look at this last part, so now we're going to put this in for these things here. So the integral from 1 to 4 of x squared e to the 18 minus e to the 6 times e to the 3 minus 1 equals to 3 dx. So these guys are all constant, so I can just tag those along and bring them out. Now, if I just integrate x squared, what's the integral of x squared?
One-third x cubed.
Great. And then I'm going to evaluate that from 1 to 4. So we'll get some silliness here. Four cubed is that 64? Right? And then that just becomes 63 divided by 9 is 7. Those numbers make sense?
Can we simplify further by distributing the e to the 3 minus 1 over the e to the 18 and minus e to the 6?
You could do that. Because, I mean, you expand it out on all the e's.
Yeah, because I'm trying to remember the rule for this. If it's e to the third times e to the 18, is
E-
that e to the 21?
Yeah.
Okay, it's addition when you multiply. Got it.
Because that's like saying you have e times e times e 18 times. And then I multiply it by another 3 e's. So I now have 21 e's multiplied together.
Okay, cool.
Now, would it have mattered if I decided to do integration with respect to x and then y and then z?
No?
No, it wouldn't have, right? Because of that theorem that we talked about in, where's Fubini? Fubini, right? Fubini's theorem.
Right.
That's the one. As long as it's a continuous function, we're fine. Now, the book does this math and magic trick, which we should have all just obviously seen. Which, to me, I'm like, it takes a big leap of faith to believe this. They also don't prove it. But if my function in this problem was this guy, if we said f of x, y, and z, that is x squared times e to the y times e to the 3z. Right? Nothing fancy there.
But that does, yeah, okay, that's not the fancy part. Okay.
Yeah, right. Let's not get too excited yet. We didn't do anything. We just rewrote it. Now they're saying that I could have wrote this triple integral that what we did there as why? Does this work?
I'd say yes, because if you look at it from the point of view of the x's, the y's and the z's are just constants and can be pulled out. Because now all those different variables are separated.
Exactly. That's the trick here. Now, if it was like something that said sine x plus y in there, we could do
Then
it.
no.
But because these are now viewed as a product, and when we're integrating with respect to the other variables, they're just numbers.
Constants.
Yeah. So let's integrate this and see if we actually end up getting that 7 times e to the 18 and all that stuff.
Got it.
That's gonna be
Whoa, you get the same thing. That's crazy.
so this is gonna be 27. Wait, that's not right. This should be what's 63 divided by 3? 21. There we go. That should be a 7.
I was wondering where you're getting that 7 from.
There we go. There we go. Yeah, so we got the same thing. So now this only works if we can actually separate those as a product of 3 different functions, where this is actually a function of x times a function of y times a, let's do m, function of z. If there's not a way to pull these apart, like I said, for example, like sine of x plus y, we couldn't integrate it that way. Only if they can be pulled apart that way. Does that make sense?
E.
Okay, cool. All right, so here, evaluate a function where we have this triple integral over this region W of this function just z dv, where it looks like the thing on page 888. So we have this weird shaped thing, and we have this region D beneath it, kind of projecting up onto that bottom part there. So let's look at this. Let's see if we can practice drawing this. Let's do it in a pencil first. I have a good pencil. Hold on. Oh, it's out of left. There we go. Oh, see, that's why we do in pencil. There we go. Yay. Okay, so there's my picture. So I'm gonna outline it. There we go. So this top point, z equals 3x plus 5. They're calling this region beneath it, this rectangular box, which is this projection underneath there. So that's D. This face here, they're calling him, or this thing here is W. And what else do we need? This number back here is a 2. This right here is a 3. This is my x-axis. This is my z-axis. Once, of course, y, and it's going back that way. And let's see. Oh, and this plane here, so this is the plane above it. That plane beneath here is z is x plus y. There we go. D is defined by this lower rectangle, 0, 2, cross. Oh, no, 0, 3. 3 is my x. There we go. 0, 2. All right. So how do I set this up? So if I look at this integral, I'm going to have my function so that means my z's bounded by my lower function would be x plus y. And then my upper function, 3x plus y. So there's my up, and technically square brackets don't mean anything. I could have done parentheses. Just want to make sure that we see these guys as my bounds. Do y'all see that? And then my y so technically I guess I could have wrote him as a 5y. So my y values, my smallest one would be 0, my big one would be 2. And then my x's, 0 to 3. So if I put those in here, my function, this guy is just z. And then oh no, that's the lower bound. I didn't bring my white out. Damn it. That makes sense. See what y'all can get for that. And as a hint, we will actually get a number. And it's a whole number. So I'm gonna pause and write up my work. Did y'all get y'all's first one done? Yes, no?
Yes.
All right. So let's see if we're on the right track, or at least if I'm on the right track. So what y'all got for the inside part? You could have left it alone at this stage. It's just that you would have to then worry about substitution in that next integration part. If for those of y'all who didn't expand out to this, did y'all just stop there? No, y'all expanded it out. Angela, is that what you did?
I'm doing the exam right now.
Oh my God.
At least it's
Gave us a
productive.
week. You gave us a week. I'm doing it 2 days early.
Okay. All right. Okay. Mary, are you on this part? Do you see it? Good. Okay. All right. Cool. Okay. Now I'm going to integrate with respect to y. So that's gonna give me what's squared y. Oh, no, 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 no. Is that what y'all got? No? What'd you get, Josh?
Nothing yet.
Oh. Are you working on the test too?
No, actually, I'm trying to do this, but my mother is distracting me. My apologies.
Remember the rules. Parent interrupted. That's a shot.
Later. Later.
I see where you're getting it though, so
Okay.
that counts.
Okay, that's good. So now this one should be easy to integrate, right? So that's going to be 8x cubed over 3. $27 by 3 is 72. 14 times 9, 6. 126. And then 3 is 96. 14, carrier 110, 12. Yes, no.
Yes.
Good. And you
That's
got
what
it,
I got.
Taylor? Awesome.
Wait, so what is 29 indicative of? What does that even mean?
Wait, 29. What are you talking about? 294.
Yeah.
Oh, so the 294 is the volume of this funky thing.
Cool.
So it's not exactly a pyramid. It's like a box where one of the top corners got sucked into the corner beneath it. That's how I see it. Yeah. It's weird. So yeah. There's that one, and we have a couple of more, but I don't think we have enough time. We have 6 minutes to get through the next one, so I don't think that will be enough time. So we'll pick up there on Monday. I'll be working on typing up more notes for y'all. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more sections that I would like us to get through. Technically, once we get to 15.5, we covered what was mandatory for the class. But I would like us to get through some of the 16 stuff and 17 stuff if we can. Because I think it would be beneficial, especially for those of y'all who do plan on going to grad school, to have some sort of exposure to this stuff. So yeah, and I might throw in 15.6. The syllabus says we're not doing 15.6. But I think the Jacobian is kind of a neat application. So it's talking about how areas change as you're warping or projecting them onto different surfaces. So kind of helps you
What's
understand.
16 and 17 over?
16 is going to be vector fields. Yay. I know y'all love slope fields and all that stuff. So it's going to be very similar to that. And then chapter 17 is the big theorems, the Stokes theorem, Green's theorem, and what's the other one? Stokes, Green's, divergence. So yeah. I definitely remember divergence. I remember Green's theorem, but it's not the same as Green's function, but they're related. So those of y'all took DiffyQ. Sure y'all are going to be really excited about seeing that stuff again.
Not at all.
Yeah. So, yeah. So that's coming. So hopefully we get to it, because I would like us to see it. The stuff that we'll see in chapter 17 is going to be more theory based, as opposed to just like, here's a problem, compute these integrals or take the derivatives or the partials. So it's going to be a little bit deeper than that. I don't know how that's going to translate through all of this stuff, because when I was taught this stuff, we actually were like in class and like having discussions on this stuff and not just looking at a screen. So we'll see. So yeah, but we're almost there. We have only a little bit of class left, which kind of makes me sad. So, but yeah. All right, guys. Well, keep working on that test. I will also write a little quiz for y'all so we can get those points. Because like I said, I want us to have at least 12 quizzes. So that would mean extra points in the long run. So, all right, guys. So I'll have office hours. I'll be hanging out in a Zoom room for y'all. Just click on that if y'all need to talk to me. And if you want to have your own social media, I can do that too. And also start looking at your classes to register, and make sure you contact your advisor before you start talking about changing your grades to like the whole pass fail thing to make sure you can legally do that. Because you don't want,
Hey,
don't want to
So-
postpone your graduation because of that.
speaking of, what do you mean register for classes?
Oh, whatever, Angelo. Assuming you make it through this semester. So
Oh, I'm gonna make it through this semester.
yes, I know
Yeah,
you're gonna
I
make
got some pretty great.
Freaking got him.
So yeah. But yeah, I'll be sure y'all talk to your advisor. But Angelo, don't forget to make sure you run your final degree audit to make sure all of your I's are dotted and your T's are crossed. So
Yeah, I got to do that.
yeah, so let's get that taken care of. So yeah, if y'all have any questions, just let me know and I will see y'all guys on Monday. All right, so bye guys.
Bye.